Okay, students. So we'll continue our chapter 2, the first part, that is physical properties, with activity 2. Alright, for this session, students, you all have to draw a line between the soil components. Okay, you can see here the soil components that we have iron oxide minerals, iron sulfate minerals, calcium minerals, low oxygen and organic matter, and the color that is added to soil. Okay, over here. So what you all have to do, draw a line which contribute to the changes in color. Example, if the soil contains a lot of organic matter, so it will be in black in color. So you have to draw a line to black. So you have to do. I already give one example. Still left with 4 more soil components. So I hope you all will draw it correctly. Let us continue our session with the next part, that is soil chemical properties. So for physical properties, we look into 5 things, that is soil texture, soil structure, soil density, soil porosity and soil color. And here for soil chemical properties, actually about 9 chemical properties. Overall, we have 9 soil chemical properties. But for your level, for your diploma level, we'll touch on 4 basic things. That is EC, or cation exchange capacity, or base saturation, soil pH, and also soil conductivity. We will have soil oxidation, soil reduction, the electric conductivity, a lot of things. But for your level, just these 4: CEC, base saturation, soil pH, and also soil conductivity. Okay, what is CEC? CEC means colloid. What is colloid? Colloid is humus. Right. Colloid is part. It's like a sponge. Colloid is like a sponge where when we put, what will happen when you put or when you throw sponge in water? What will happen to the sponge? It will absorb all the water, right? So colloid is similar like sponge. It present in water. It present in the soil. The more the amount of colloid, that means the higher the CEC of the soil. But here in soil, the main role for colloid is it will absorb all the nutrients. All the nutrients in soil are bind to colloid and also water. A simple example for this: what will happen if you apply fertilizer in soil? Does the fertilizer directly go to the plants, or it remain in the soil? Yes, these kind of questions will be answered when we look deeper into what is colloid, what is humus, what is CEC site. Right. There are 2 main subdivisions in colloid, or 2 main parts, or 2 examples for colloid. That is clay and also humus. Okay, in your first chapter, we did mention that we did comparison between organic soil and also mineral soil, right? So that shows soil we have 2 types, that is organic soil and also mineral soil. The rest will be varies according to the series, according to the affected with other external factors. So mainly we have 2, that is organic soil and mineral soil. In mineral soil, the clays will act as colloid, while in organic soil, the humus layers will act as colloid. So remember here, where a lot of clays will be deposited in soil, in B layer. That means a lot of nutrients will absorb, will stay in B layers. If you still remember the soil profile that we checked in chapter 1, we have A layers, O, A, B. In one of the chart that I show soil profile, it mentioned E, got additional E layer, right? Yes, E layer is the layer that works to bring down the nutrients. You will apply fertilizer in O horizon, A horizon, so the nutrient will be leached, will bring down to B, and it stay in B. It will not go to C. It will stay in B, and because B layers contains a lot of colloid for mineral soil. A lot of minerals also will stay in O horizon because it's full with humus. Vice versa for organic soil, fully humus. For organic soil, like peat soil, right, it's really hard to differentiate the A layers, B layers, C layers. In Malaysia, organic soil, how to explain to you all? Okay, organic soil actually is not a soil. It's just a layer of humus. We have two type of organic soil, that is deep peat and also peat soil, that is deep peat and also shallow peat. Except for Sarawak, the rest of the area in Malaysia or Sabah contains shallow peat, which the peat level be about 1 feet, 1 feet high. That means 1 feet means about 30 cm. After the peat layer, you will find normal mineral soil. So in Malaysia, normally we will have acid sulfate soils below the peat areas. So if you don't believe me, you can do soil profile at peat areas, then you will find the acid sulfate soil below the peat soil. The characteristics of a colloid is the size is less than 1 millimeter. Very small, very tiny. You cannot see by your naked eye. You have to use microscope to identify colloids. Larger surface area than sand and silt. Yes, although the size is small, but contains larger surface area. So it's the major determination of water holding capacity in soil and also nutrient holding capacity. Just a function of colloid. Means if your soil contains a lot of colloid, that means it can hold a lot of water, and also it can hold a lot of nutrients. This one you have to understand colloid like exactly act like sponge. Sponge got a lot of pore spaces, right? So just imagine colloid is a sponge. It's got a lot of holes, ruang-ruang kosong atau pore spaces, means ada micropores, macropores, ada lubang besar, ada lubang kecil semua kan. But each of these holes will be absorbed, will like ada perumah, ada hose. The hose is water and also nutrient. Most of the chemical process or chemical reactions in soil happen in colloid surface. You can see here cation exchange capacity, cation. So what is cation? What is anion? Why it's called cation exchange capacity? Okay, this one you will find in the next slides. And also cation exchange capacity also determine the soil reaction in the soil, whether the soil is acidic or alkaline. And cation exchange happens in colloid. Okay, this one. Okay, here the basic will have mineral clay and also organic humus, but we have 4 type of colloid. Organic means humus. For clay, we will have 3 type of clay. Inorganic clay, you can see here inorganic clays, that means doesn't have organic layers in it. It's a crystalline silicate clay. You can see the shape of the clay. It's crystal in form. The second one is inorganic, and the clay is ferrum and aluminum oxides. Non-silicate clay doesn't have any silicate. You can see here contains silicate. In the clay you have a lot of silicate. These two doesn't have any silicates. Usually these two, like in this one, if I look into it, this look like mica. These two you can find in high temperature and high pressure areas. If high temperature and high pressure areas means either volcanic soil or the soil that always have earthquake, the area that always have earthquakes. Okay, it'll be in this shape, and this one non-crystalline silicate as well, but in volcanic ash. All right, so we will, if questions come out, determine what is the colloid layer in mineral soil. So your answer will be clay. What's the name of the colloid in organic soil? Is humus. If question come out, list down 4 type of colloid. You have to list down these 4 colloid types. You only have 1 organic and 3 non-organic. That is crystalline silicate, non-crystalline silicate. That's the bind with ferrum and also aluminium. And the other one is non-crystalline silicate as well, but you can find in volcanic ash. Alright, yes, you can see these platy layers, right? This is colloid. Okay, these colloids are when your soil contains low CEC means okay, let's say example, when you take a soil sample, you send for soil analysis, and the results come out, and the results shows your soil contains low CEC. Okay, what does mean by low CEC? That means it contains low colloid layers. Okay, before we touch on all those things, can we see low CEC, high CEC? What do you understand by this picture? In this picture, there are a lot of nutrients. Okay, these are our nutrients, our elements, or whatever fertilizer that you apply always have these elements. Okay. These are 2 types of soil. In which soil a lot of nutrients are absorbed or stay, whether in low CEC soil or high CEC soil. Okay, from the picture itself, you all know that high CEC contains a lot of elements, a lot of nutrients bind on it. Why? Because it contains a lot of colloids. Okay, he say here, right? These areas we call it as cation exchange site. You can see here. So when you have a lot of colloid, that means you have a lot of cation exchange site. I mean, more nutrients will have spaces to go and bind in with the colloid. So what will happen? Plant roots cannot take the nutrient directly from soil. You apply fertilizer, the fertilizer will go and stay absorbed by colloid. Once absorbed by colloid, the plant roots will uptake the nutrients and bind with the colloid. You cannot take freely available nutrients in soil. If the nutrient in the colloid, it will take the nutrient. It's always need a medium to absorb the nutrient by plant roots. This is why you cannot pump in, you cannot throw, you cannot waste your fertilizer. You have to do soil analysis to determine whether your soil contains low CEC or high CEC. If results come out with your soil contain high CEC, means yes, you have to. There are calculations that then you have to work out whether you can apply more fertilizer or less fertilizer. Compare vice versa. Compare with low CEC. If low CEC means you cannot apply a lot of fertilizers at one time. All right. Thank you, students. We'll continue in our next video.